All right, this is 7.1. We're going to talk about substitution. But you guys have talked about solving using substitution, solving using elimination, and solving by graphing. All right, we're going to review all three of those. Now, on your web assign, it's going to say solve by using substitution. So what do you have to use? Substitution. Tomorrow, it's going to say solve by using elimination. So what do you need to use? Elimination. All right, if it's a solve by graphing, you need to graph it. On your test or quiz, I'll probably give you one that says solve by this, one that says solve by this, then the rest of them are just solve. Do whatever you want. 90% of us will say elimination is easier. We like it that way. That's how I am. But it's important to know how to do all the different methods just in case, sometimes they're set up to where one leads itself to substitution and one leads itself to elimination. So when we are doing substitution means to plug something in for something else. So here are the steps that you guys were taught early on in algebra. When you set one equation, you want to get one variable by itself. Then you plug in that statement or that expression into the other one. You solve, plug it back in. The beauty of systems of equations and solving equations is at the end, you can tell if you are right or not when you plug it back in. On WebAssign, they're going to ask you, is this a solution? The way that you show me is it a solution is you take the x and the y that they give you, plug it into the x and y, and see if it works or not. So in a case like this, guys, for number one, there's 4 different ways you can solve this. So I'm not going to do it all 4 ways. You guys, we're going to pick one variable we want to substitute for, one we want to solve for, however you want to say it, and then which we're going to plug into the other equation. So in this first example, good morning, honey. In this first example, I'm going to solve this second equation. I'm going to solve it for x. Just because to me, when I look at it, it just looks easier. So if I solve this for x, would you guys agree that I would add y to both sides? Yes? So I get x equals, I'm going to say y plus 2. Can I say 2 plus y? Yes or no? Yeah, because we're just adding. So what I'm going to do is I'm going to take this expression and I'm going to plug it in everywhere I see an x in the top one. Everybody with me? So instead of x, I'm going to write y plus 2. And then I have plus y equals 4. Okay, so now we're adding. I have one y here and one y here. That gives me how many? So I have 2y plus 2 equals 4. Now what? Subtract 2 from both sides. I get 2y equals 2. Now what? Divide by 2. And I get y equals 1. Okay, you guys solved an equation. You got y equals 1. How do I figure out what x equals if I know what y equals? You're just going to plug it back in. So I'm going to say x plus 1 equals 4. So I subtract 1 from both sides. Agreed? X equals what? 3. If I use the bottom one, I'd have x minus 1 equals 2, right? What do I do to both sides? Add 1. So here I get what? X equals 3. Agreed? So you write your answer, ladies and gents, as an ordered pair. When we write as an ordered pair, what comes first, the x or the y? So I would write 3, 1. Circle it. Questions? All right, if I look at this next one, this is a little different because it has a squared in it, but we just solved the exact same way. What do you think would be the easiest thing to solve for? The x on the bottom. Okay, why is Bella saying that? Okay, it doesn't have the squared. I can solve for the y as well, right? I'm going to solve for the y. Why? Again, because there's 2 x's at the top. Good, but you still could, however you go about it is fine. So I'm going to take this second equation and I'm going to solve for y. That means I want to isolate y. So the first thing I'm going to do is what? Okay, I'm going to subtract 2x from both sides. So I get negative y equals negative 2x minus 1. Now what? Divide or multiply by negative 1. Good. So I get y equals 2x plus 1. Questions? If you have one, please ask me. So I'm going to take this expression right here, 2x plus 1, and I'm going to plug it in right there. So when I solve this, I have x squared plus 4x minus 2x plus 1 equals 7. Very important that you guys pay attention to what you're doing. Can I just go through and just, bam, combine like terms? Why not? I have to distribute this negative, right? So I have x squared plus 4x minus 2x minus 1 equals 7. What can I do now? I can combine 4x and 2x, right? So I have x squared, 4x minus 2x is plus 2x, minus 1 equals 7. I have a quadratic, so I need to get everything to one side. What do I do? Minus 7 from both sides. So I'm left with x squared plus 2x minus 8 equals 0. Do we know how to factor? What times what gives me a negative 8 when I multiply, but a positive 2 when I add? Perfect. X plus 4, x minus 2. Agreed? So if I solve each of these, I have x plus 4 equals 0, x minus 2 equals 0. So over here I get x equals what? Negative 4, and over here I get x equals what? 2. Agreed? So how many solutions do I have in this case? Possibly 2. How did I know at the beginning that I might probably have 2 solutions? Because it's squared. So how, if I know now what x's are, how do I find out what y is? You just plug it in. So I can say 2 times, what's the first x I found? Negative 4 minus y equals negative 1. What's 2 times negative 4? Negative 8 minus y equals negative 1. Now what? I'm going to add 8 to both sides. So I get negative y equals 7. So y equals negative 7. So I found one ordered pair as when I plugged in negative 4, I got out what? Negative 7? Yep.
Mm-hmm.
I would always go back to the original. Okay. Always, always, always. Just kind of, it's a good kind of rule to follow. So now I'm going to try 2. So I'll go back to the original, 2x minus y. So 2 times 2 minus y equals negative 1. What's 2 times 2? 4 minus y equals negative 1. Now what? Subtract the 4. Negative y equals negative 5. So y equals what? Okay, so when I plugged in positive 2, I got out what? Positive 5. So you got 2 solutions. How do I know for sure that both of them work? You just go back and plug it in. In this first equation, x squared plus 4x minus y. Just in your mind, guys, what's negative 4 squared? 16, right? Plus, what's 4 times negative 4? Negative 16, right? And then I have minus negative 7. Well, 16 and 16 cancel out, and minus a negative gives me a what? Positive. So this is right. This one works. Now do the same thing. I don't have to see the check. You guys can just do it in your mind. You're fine. If I look here, I say plug in 2 and 5. So 2 squared is 4. And 4 times 2 is what? 8. Minus 5. What's 4 plus 8? Minus 5. There you go. They both work. So you have 2 solutions here. What's up?
Does it matter how you pair them? Like, does negative have to go with negative, or like, could it be like 2 and negative 7 and negative?
No. Good question. I solved here and I got x is negative 4. So when I went and plugged in negative 4 into the equation, that's where I got my negative 7. So that's your ordered pair. And then here I plugged in 2. And when I plugged in 2, I got out 5. So that's why that's my ordered pair. Yeah, they have to stay together. Good question, though. How are we feeling? All right, same thing here. All right, we're going to solve using substitution. I'm going to solve the top equation for y. Do you guys see why that would be easy? Okay, so the only thing I have to do here is just add x to both sides, right? So I get y equals x plus 4. Could you write 4 plus x? Yes. So I'm going to take this, I'm going to plug it in right there. So I have x squared plus x plus 4 equals 3. What do I do? I'm going to subtract 3 from both sides. Good. And I get x squared plus x plus 1 equals 0. Okay, so factor. What are the factors of 1 that'll multiply to give me 1, but add to give me 1? There are none. So if I were to solve this, I'd have to use the quadratic formula, and I would get an imaginary answer. So when we're talking about real solutions and x and y that you can plot on a graph, does this have any real solutions? So your answer here would just be no solution. All right, we're going to talk tomorrow more about no solution and infinite many solutions. That means every single number in the world will work. What does it mean when two lines have a solution? What does it look like when they're graphed? They meet. Where they meet, where they cross is the solution. Make sure you guys are aware of that. All right, 2 more, then we're done. We got some word problems, guys. If you remember, we're talking about systems. That means we're going to have 2 equations in this case. So it says a total of $12,000 is invested in 2 funds paying 9% and 11% simple interest. The yearly interest is $11.80. How much is invested in each rate? What are the 2 letters that we can use? X and Y. It does not matter what you make X, what you make Y. One of the accounts pays 9%. How would I write that as a decimal? Okay. So think about this, 0.09. How can I write 11% as a decimal? Okay, 0.11, all right? So now let's think about this for a second. I have these 2 funds. How much is invested in the 2 funds?
In total?
Mm-hmm, in total.
1,000 each.
Well, you don't know that. We're going to figure that out. It's not equal. How do you know that? What is the total that they told us? So would you agree with me that x plus y should equal $12,000? Okay. What is my second equation going to look like, you think? We're talking about interest. Well, we have a second equation. What is the interest rate that I chose for x? Doesn't matter. You can make it. It doesn't matter if it's x or y. What's the interest rate that I chose x to be? X. So if I wrote 0.09x plus what? 0.11y, what should that equal? 1180. Do you see how all of the interest stuff stays together? Right? You have 2 funds and you have a total amount that you invested. So x plus y has to equal that total. Your second equation is whatever the interest rate is on each of them, and then you can just set it equal to the interest. We're going to do more word problems to kind of keep your mind doing this, but we're always going to have 2. Now, 2 things you can do here. If you don't like working with decimals, what could we do? You could multiply the bottom by 100. That's fine if you want to do that. If you don't mind decimals, then don't worry about it. Which equation, since we have to use substitution, which equation would be easier to just solve for one variable? The top one. Okay? It doesn't matter to me, guys. What do you want to solve for, x or for y? Okay, if we're going to solve for x, that means I have to subtract y from both sides, correct? So I get x equals, does it matter now the order? It does. If I was, because it's subtraction, if I wanted my y first, it would have to say negative y plus 1,200, or 12,000, right? So all we're going to do now is substitute in for x. Again, if you don't like decimals, then just multiply everything by 100. So I have 0.09 times what? 12,000 minus y. plus 0.11y equals 1180. Now, you guys need your calculators. Help me out. What is 0.09 times 12,000? 0.09 times...
1,080.
Yep, 1080. That's what I got.
Yeah.
Minus, what's 0.09 times y? 0.09y, right? Plus 0.11y equals 1180. Questions? So I have 1080, and then I have negative 0.09 plus 0.11 gives me what? What is it? Plus 0.02y equals 1180. Now what? Subtract 1080 from both sides. So I get 0.02y equals, what's 1180 minus 1080? 100. Now what? Divide by 0.02. So 100 divided by 0.02. And I get what? Y equals 5,000. All right, so what does that tell me? Okay, great. $5,000, good, was invested at what interest rate? 11%. Very good. How did you guys know it was 11%? Because that's the beginning. That's what I put with Y. So if I know that 5,000 was invested at 11%, and there was a total of $12,000 invested all around, how much was invested at 9%? There you go. 7,000 invested at 9%. Good. But I like the way at the beginning Carlos said, oh, there's two funds. 12,000 was the total, so it was 6 and 6. You can't assume that it's equal, but does it make sense that our numbers are 5,000 and 7,000? Right? If you come out, and when you work this equation out, these two systems, and you get a negative number, and you're talking about money, that's not right. Right? If you get some random wacko number that's either super, super huge or super, super small, you know that's not right. Just go back and look where you made a tiny little mistake. But the biggest thing is to understand, you're going to have, I put some of these on your homework, is to say if you have two funds, those two funds, when they add up, should be whatever the total is that you invested. The second equation deals with the interest. Whatever the interest rate of one is, plus whatever the interest rate of the other one is, equals the total amount of interest that's accrued. Yes, sir. That's a good question. At the beginning, I said interest stays together. What I meant by that is if you guys notice, they tell me an interest rate here and an interest rate here, and the total of the interest is right here. So see in this second equation how the interest rates and the total amount of interest that was accrued all stay together. Whatever they have in common stays together. Good question. The question is, what's the final answer? The final answer is how much money was invested in each account. So, yes, 5,000 is invested at the 11% account and 7,000 invested in the 9% account. Yeah. Whoop. Okay, last one. I kept this on here. This is from the book. Break-even analysis. Guys, what does it mean if you, in business if you break even? Don't look at this problem. If I said to you guys, I mean, we broke even, what does that mean?
You got the cost.
Okay, your cost, you didn't make any money, but you didn't lose any money, right? At the beginning of any business, you invest, say, $100,000. You don't really start making money until that $100,000 that you invested is already brought back to the bottom line. So the break-even point is just a way of saying that the equations are what to each other? They zero out, that they're equal, that your cost equals your profit or your revenue. So in a case like this, it says a small business invests $10,000 to produce a new soft drink. Each bottle of soft drink is blah, 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 blah. How many bottles must you do? They want to know what is the break-even point. Where is, what's the magic number that says this equals this? All right, so think about what is the total cost, and I left this here so you guys could see it. What is the total cost of making whatever, what are we making? Soft drinks? Okay. I invested how much money? $10,000, so that's out of my pocket, right? And then how much does it cost me to produce the drink? 65 cents. So do you see how the cost, they wrote the equation that the cost is, initially I had to take $10,000 out, and then every single soft drink I make cost me 65 cents. Do you see why the X is with the 65? Because I could make 20 bottles. I could make 175 bottles. I could make 1,000,000 bottles. But my initial investment is it's my constant. It's my 10,000. So if we're talking about the break-even point, I have my cost. When we break even, it's when the cost and the revenue equal each other. Revenue just means how much money you're making. Do you understand down here why the revenue is 1.20x? Because how much money do you make on each bottle of soda that you sell? $1.20. So when they ask you, they're going to give you all the information you need to write the cost, however much it costs to make this product, and then the revenue, however much money you make on each thing that you sell. The break-even point is when they are equal. So the hardest thing is actually writing this equation, and it's not really hard. Once you guys go through this, you'll see, okay, however much money it cost me to start it, plus however much each thing costs to produce, should equal however much each thing I charge to sell. So you would literally write 0.65x plus 10,000 equals 1.20x. You're solving for x. You don't have a systems of equations where we have two variables. You're saying, when does my cost equal my revenue? So how would I solve this? Subtract 0.65, good, from both sides. So I get, what's 1.20 minus 0.65? Okay, so I'm going to write, I like the variables on the left. So 0.55x equals 10,000. Now what? Divide by 0.55. So x equals, what's 10,000 divided by 0.55? All right, I got 18,181.8. You guys get something like that? Yeah. Now, answer this in a real world problem. Can I make 0.8 cans of soda? No. So in order for me to break even, about how many cans do I need to? 18,182. I need to make about 18,182 cans or bottles or whatever we're talking about. Right? On WebAssign, if you have a question like this and you enter this, they're going to tell you it's wrong. And you guys are going to write me a note and say, WebAssign is so annoying, which I agree. But answer the question like it is asked. You can't have half of a person or an animal. I mean, I guess you could, but we're not going to go into the science behind that. But remember, the break-even point means when does the cost of whatever you're producing equal your profit? And then once you hit that break-even point, everything after that is what? Money in your pocket, profit.